Hello, guys. Welcome back to Math Zone African Motives. We are still on our power machines, and in this case, we are going to consider the part of our interpolation, which is going to affect us when we are working with our steam tables. So this part actually, you can use it for your N5 and also your N6 power machines. There are some typical questions, all right, that you will need to apply the interpolation concept. Let us take a consideration from our steam tables. I want us to understand what exactly we have here. If we are given, let us say, a certain pressure, right? You have got a certain value of pressure. From that value, let us consider maybe 5 kilopascal. Remember, our pressure is given in what? In kilopascal. It has corresponding values, the TS, VG, HF, HFG, all these up to the last one. The values are given corresponding to that. All right. So our question is, let's say we have got a certain pressure that we are given there, but that pressure is not represented here. We do not have that pressure, but for that pressure, we are going to need maybe the TS, the VG, the HF. From what? From the given pressure, which is not corresponding. Maybe we have got something like 7,2 kilopascal, and we do not have 7,2. We have got 7,0, 7,5, but 7,2 we do not have. So that is where you can use the interpolation method, which is to obtain exact values for that given pressure. So there are actually so many ways that you can do this. So I'm going to explain in this video the first method where we are to determine or to find any of the given values, but we are not having what? The pressure. So in our case here, it is a condition where we are given a pressure, right? So let us say we are given a pressure, not in what? In steam tables. So it is not available in the steam tables, all right? So adjustments can be made from that. So what we can actually do, like we have a given pressure, and for that pressure, let us say we need to find any of these, all right? We need to determine any of these corresponding, all right? From what? From the given pressure, we need to determine any of these that are given. So that is the concept that we are going to what? To consider. So you need to select, all right? We must actually select a set of data slightly above and slightly below the required value and perform the interpolation. So to use the method that I'm going to explain, let us say we're given a pressure, which is P. I'm just going to consider any pressure that we are going to work with so that we can have that one as our example, right? So I'm just going to use that as our example. Let's say we are given a pressure of, all right, given a pressure of 11,33 kilopascal, all right? For this pressure, we need to determine the corresponding values, all right, such as, all right, for given a pressure of 11,33 kilopascals, let us say we just want to find, all right, let us consider the most important. In most cases, you are being asked to calculate or to determine HF and HFG. Those are the most cases. But in our case, guys, like I said, we can use this to determine any of these, but I'm just going to consider HF and what? HFG. All right, so this is what you are going to do, so you consider that the 11,33 is not in our steam tables. We do not have that. So what you're going to do is to select, all right? So you are going to select a set of data, a set of what? Of data. You are going to select a set of data slightly. So you're going to consider something that is slightly above, all right, above the value of that 11 comma that you're given, and slightly below, all right, and slightly below the required value, and perform calculations and perform the interpolation. So it can be applied in different ways. So if we are given a condition of like this, we've got a pressure that we are going to use as an example, which is 11,33 kilopascal. So there are so many things that we can actually determine from the given pressure. Like we saw that we can have the value of TS, we can have the value of VG, we can have the value of HG, SF. All those values can be determined using the same concept, but I'm just going to explain using HF and what? HFG. So this is the way that you're going to apply. All right, you consider the values, all right, which are affecting the pressure, which is 11,33 kilopascal. This is our example. So this is our example, 11,33 kilopascal. This pressure here, it is found in between two consecutive values according to our steam tables. The 11,33 kilopascal, it is found between which values? All right, so let's consider here. We do not have, all right, so guys here, be very careful. The first part represents the pressure, remember? So we're under the pressure. We can see that we have got 10, 11, 12, 13, 14, but we do not have 11,33. So 11,33 was going to be in between. It was going to be somewhere here, 11,33. In between these two pressures, the pressure of 11 and this pressure of what? 12, according to the ones that we have here. So it's in between 11 and what? 12. 11 being the one below and 12 being the one above. So those are the ones that I'm going to work with, all right? I'm going to work with those two pressures, that is 11 and what? And 12 in between. Please be very careful about that, all right? So this is it. So this is what I'm trying to say. 11,33 kilopascal is actually greater than 11 kilopascal, but less than what? Less than 12 kilopascal. So these are the boundaries that we are going to use in terms of what? In terms of the pressure. So using this method, you are going to draw a triangle from the given pressures, all right? So you're going to have something like this, all right? Let me just try and see if this part is going to make sense, all right? So you're going to draw, just have something like this, all right? So you're asking yourself that at this pressure, what are the values corresponding? And at a pressure of 11, what are the values corresponding? So taking the vertical axis as your pressure, this is our vertical axis, our pressure in what? Kilopascal. Let's say this is where we have got 11, all right? And 12 is somewhere here. So it means that the 11,33, remember, it is found what? In between these two. It is in between. All right, so let's say in between we have got that. All right, let me just try to have it a little bit on top here. This is our 12. And in between, let us just say we've got 11,33. So these values, they correspond, these pressures that we see here, they correspond to these values now, the HF, HFG, TS, whatever that you're given. So meaning to say at a pressure of 11, at this pressure of 11, we are going to have a corresponding value. We are going to actually have corresponding values in the vertical axis. So in this horizontal axis, and what you have in the horizontal axis is or can be any one of these. Any one of these. So in our case, like I said, I'm just going to consider HF and what? HFG. So those are the ones that you're going to take corresponding. So you're going to see that the 12 was going to correspond to the maximum value, and we have got those values corresponding to the horizontal, and the 11,33 was going to do the same thing corresponding to a certain value, all right, that we do not know in this case. So these we're going to form a shape which is actually going to form a triangle from there. All right, you're going to form something like this. All right, if you join these points, all right, and from this starting point, you're going to have this horizontal line from the starting point and this vertical line at the end. Join those like that. And in between, these pressures in between 11 and 11,33, also you're going to join that part like this. All right, so this is what you're going to have, which is we have formed a triangle actually from what you have. So the horizontal axis is for the values which correspond to the what? To the pressure. The pressure of 11 in our case, considering finding HF and HFG, HF and what? HFG at what? At this pressure. We are going to focus with that at 11 kilopascal now from your what? Your steam tables. What is that you have at 11 kilopascal at the given pressure? What are the corresponding values? So you consider in that manner like this. So these are the values that you're going to have, but in this case, I'm not going to use everything. I'm just going to focus on HF, which is what? 200, and HFG, which is what? 2388. So those are the values that you're going to what? That you're going to use corresponding to what? To 11. So you've got your HF and your what? Your HFG. All right. So these are the values that you are going to have. So that is, let us start with HF 200. So you're going to take that value of HF, which is 200. Sorry for that. It's now, let me just remove it. All right. So this is it, guys. Let us go back. We said HF. So these are the values, remember, in the horizontal HF, HFG. So if you start with HF, make sure that it is corresponding, all right, to 11, the HF that is at what? At 11. Yeah, all right, then you move on to HFG like that, the value that you're going to obtain. So we said HF at 11 is what? At 11, we saw that the value is 200, right? That was it. The HF there at 11 was 200. So you take that value as it is 200. All right, so this is 200. And our HFG at that point, at the same point where we have got our 11 kilopascal, our HFG was given as what? 2388. So you take that value as it is, all right? 2388. So this is what you have for HFG, 2388. So if you wanted maybe to determine VG or HG or TS, you do the same thing, guys. The TS, what is the corresponding value? The VG, what is the corresponding value? Whatever that you want, you take it corresponding to that. But in our case, I just want to focus with HF and what? HFG like that. So let us move on to another one. So we are focusing with what we have. Remember, 11 and 12 are the ones that we have from our steam table. So you focus with 11 and what? And 12. So 12, you do the same thing. It is corresponding to the maximum here, and these are the corresponding values. HF, what is the value of HF at what? 12 kilopascal at that pressure. All right, so we're going to need the pressure this time. It is what? 12 kilopascal. What is the value of HF there? This is our HF, and this is our HFG from what we have. So you're going to take your HF 207, your HFG like that. All right, so you're going to take those values as they are. Our HF, we said it's what? Our HF is 207. Our HFG at 12 kilopascal, we saw that it was 2384. This is what you had. All right, so you take corresponding, if it was temperature, you take the temperature corresponding, the volume corresponding like that. So what is the purpose now of this triangle? It follows that these two triangles that we have, they are similar. If we take them as right angle triangles as they are, these two triangles are what? Are similar. The two, all right, the two triangles are what? Are similar. So if they are similar, it follows that I'm talking about the first triangle, this one, the smaller triangle. This is our first triangle. The second triangle, which is the bigger triangle. All right. So let's say we consider that they are similar, these two triangles. We've got what? The smaller triangle and what? The bigger triangle like this. Those are the two triangles that I'm referring to. So on the smaller triangle, you are going to take the horizontal as a, on the smaller triangle, we're going to take this horizontal side, this one, as your A, which is the difference between the HF that you're going to have at what? At 11.3, the one that we do not know. The corresponding minus 200, that is our A. And this side is going to be your B. All right, so you take that one as your B. The difference between the pressures 11,33 and what? 11, the difference, that is our B. And C is going to be taken on the bigger triangle. So this is A and this is B on the smaller one. Then the bigger triangle is going to have what? C and what? C and D. So A, B, C, D. Take note A, B, C, D like that. All right. So meaning to say our C from the bigger triangle, C represents the difference from the values that we are given. The difference here, that is our C. All right. So that is our C. This one. On the bigger triangle, that's our C. And this is our D. On the bigger triangle, the difference between these two, that's our D. So it follows that since these two triangles are similar, the smaller and the bigger one, they are similar. The ratio of sides, guys, corresponds. Remember, A over C is equal to, you can have that way, the way that you want. A over C is equal to B over what? Is equal to B over D, whatever that you want. Or you can say these corresponding sides, A to B, A over what? Over B is equal to C corresponds to what? C corresponds to D. So you can use any formula from the ratio of sides. You can take A over B, C over D like that. So if these two, they are equal, which is from what? Ratio of what? Ratio of sides. Take note, guys, this is from our mathematics, and we must be very careful about this ratio of sides. If you take it, A to C, B to D, it's fine. You can have it like that. Or you can take it this way that I've done, A to what? To B over what? C to D. So this is the ratio that you're going to have. Using this ratio, you can solve for any value which is unknown on these values, this one. Using this, you can find these. Remember, these are the ones to be what? to be calculated any one of these. But in our case, we are focusing with what? With HF and HFG, the ones to be what? Calculated. So let us apply this mathematically. You'll see, guys, very soon when I have our answer. So this is what you're going to have. A represents the distance from the smaller triangle, this difference, actually, the difference. So simply subtract. Let's say we want to calculate, there are two things here, HF and what? HFG. So for HF, right? Let's start with what? HF. We are going to take that ratio, A over what? Over B is equal to what? C over D, right? So let's find what? HF. So it follows that A is the difference on the what? On the smaller triangle, this one, the difference. So it simply means what? HF minus 200, the difference. So it's HF minus this. We are focusing on HF. So that's a difference. So that's HF minus what? Minus 200 over B. B is the difference here in terms of the pressures. So on the smaller triangle, the maximum is 11,33. The smaller one is what? 11. The difference. So you subtract, that's your B. So 11, what? 11,33. 11,33 minus what? Minus 11. That is for pressure. So B is representing what? The pressure, which is equal to C. C is the what? The difference here that we see. So it is the same as what we had on A to say HF minus 200. But C, guys, look at C from the beginning up to the end. So you're talking about what? 200 minus this, the difference between that. So it's 200 minus what? 207 minus what? Minus 200. So that's 207 minus 200. We are focusing with where HF is in this line of HF over what? D. So if we check properly, our D from our diagram is the difference in the pressures now. 12 and what? 11, the difference between these two. So that's 12 minus what? 12 minus the maximum there, 12. The minimum is what? 11. The difference on the pressures, that's our D. 12 minus 11. Guys, we have formed an equation which you can use to calculate what? HF from there. Which you can use to calculate HF from there. From this value that we are given, or from this formula that we are given, we can calculate our HF from there. So that is the correspond. That is all right. I'm going to formulate a formula from there. So I want you to see something now. I'm going to formulate a formula that you can easily use very soon. All right, but I want you to see where actually it is coming from. So you're going to find what? The value of what? HF. Remember, you will need to calculate HF. That is our unknown value. So that is in this equation, we only have one unknown value, which is HF. So it allows you to calculate HF from there. All right. Anyways, let us say we wanted to calculate, in this case, HFG. So you can use for anyone, TS, you do the same thing, VG, the same thing. All right. So for HFG, let us form the same thing. For HFG, using the same formula, guys, A over B is equal to C over D. What is our A? But we are considering, or we are focusing on what? On this row of what? HFG. That is where we are focusing on. All right. So our A for the smaller triangle, HFG minus this one, the ones that are corresponding on the smaller triangle. That is what you're going to have. So it's going to be HFG minus this one corresponding to that. So it's HFG. All right. Sorry for that. So it's going to be HFG minus what? Minus 2388 over what? B. Remember, B, guys, does not change for the pressures. So the difference between these two pressures, 11,33 and what? 11. The difference between those two pressures, that is what? That is the part of B. So it's 11, just like what we had here. 11,33 minus what? 11 is equal to C. C representing what? For this HFG, for this HFG, for this row, Our C is the one affecting the bigger triangle. So the maximum value there to the minimum value. So that's 2, 3. That is the difference between these two. So that's 2, 3, 8, 4 minus the one and the minimum there, which is 2, 3, 8, 8 over what? D. So D is the same, the difference here on the pressures maximum minus minimum, 12 minus what? Minus 11. The same thing that we had here. So this one is not going to change. 12 minus 11. So you formed an equation, guys, from this, which we can use to solve for the value of HF. And the second one can be used to solve for what? For HFG using this method. So like I said, there are so many ways, but here I just want you to know from the basics. So it follows that in order for you to solve for HF, guys, you're going to see that from this value that we are given here, this value here, you are going to take that value, all right? You cross multiply, or actually you multiply by that. So you're going to have something like this at the end. This part that you are seeing here, 207 minus 200 over 12 minus 11, then this, you multiply it since it is in the what? In the denominator. It is in the denominator. So you can simply remove it here by multiplying by it both sides. All right. So you're going to multiply by that here, 11,33 minus 11. So meaning to say you no longer have this in the denominator. You are left with what? Minus 200. So what we're going to do with that minus 200, you are simply going to take it to the other side of the equation since it is what? Under a subtraction. So you're simply going to add that 200, or you simply start with that 200, you add to this part that you that you multiplied by the what? By the denominator. So this is what you're going to end with at the end. You're going to find that your HF is equal to what you have here, but remember the minus 200 is just going to be added. All right, so you can just write here what you have already. If you do not want to be mistaken, all right, you can just say what I have originally, 207 minus 200 over what? 12 minus 11, all right, times this denominator of what? 11,33 minus 11. Then I'm going to add the 200 after everything. The 200 there is going to be what? Is going to be added to my answer. So that is the condition that you are simply going to have at the end. So your HF is calculated from this, all right? So that is what you're simply going to have, guys. You can have that value, which was corresponding at 11,33, the one that we're not having. All right, so that is it. This is just another way, guys. There are so many ways. That's what you can actually have. So this is 207 minus 200. All right, everything over 11. All right, 12 minus 11, that's a 1. All right, there was no need here for having this. But anyways, that's it. 11,33 minus 11. All right, then we are going to simply add 200 to that. So that was going to give us 202,31. All right, so this is 202,31. So that's our HF. Remember, the units of HF, it is taken in what? Kilojoules per kilogram. So that was the corresponding value of HF in what? Kilojoules per kilogram, which is using this method. You can find the corresponding value exactly to that given pressure that we were not given of 11,33 kilopascal. Simple like that. So if you know these guys, you're not going to even have a lot of things. You just, okay, just made my explanation having a lot of things, but you see that it's not going to be a lot if you know this formula is just solving direct. All right. So if you see it is the same thing here, you're going to multiply by this denominator here, then you take this one to the other side, it will be a positive. So therefore, our HFG was going to be 2384 minus 2388 over what? 12 minus 11 times the bracket here of what? 11,33 minus 11. Then remember, this has to be added to whatever that you are now having here. You are going to add the one that was subtracting, you add that 2388. So that was it. You have got your HFG from there using your calculator. You can evaluate this value that we are given. So here it was going to be 2388. All right, this bracket is the same here. I have to change the numerator. All right, so here it's all about the numerator. 2384 minus what? 2388, like that. So this was going to give us 2386,68, right? So that's 2386,68 kilojoules per watt per kilogram. That's a method that can actually be applied to what we are given. So that is for any value that you are to determine, we can have it in this manner. If we are to formulate this formula, like I said, guys, it is not only about determining HF and HFG. No, it can be for anything. So here, let me conclude then. I will give you a formula, guys. So here we are saying that's at given pressure, that pressure that we're given, it was what? 11,33. At given pressure, 11,33 kilopascal. All right, at 11,33 kilopascal, our HF. All right, guys, instead of rewriting, let me just show you. Your HF is this, and your HF is that. That is the at this given value of 11,33 kilopascal, these are the corresponding what? Enthalpies, HF and what? HFG. So if we are to conclude, I want us to see, guys, what is actually happening here with a formula. It follows that if here you are to calculate TS, all right, let's say you are to calculate TS, the pressures that are in between, all right, the pressures that are in between, the pressures that are the boundaries for that 11,33 kilo, the one that you're given. So let's say this is our P, the given what? The given pressure. So we can say the given pressure P is greater than P1 but less than P2, where P1 and P2 are the boundaries. So P1 simply representing the lower value, all right? And P2 the above value. So let us say we've got the lower value, and this is the above value or the upper value. This is our upper value. It follows that at these pressures P1 and P2, you are going to have corresponding values for HF, if it is HF, or HFG for TS. Those corresponding values, you are simply taking them. Let's say at P1, you are going to have your corresponding values as H1, right? If it is for HF, whatever that you have, if it is the temperature, you're going to have T1. If it is the volume V1, whatever that you have there. Then at P2, the same thing that you're going to apply to say, all right, at that pressure P2, you're going to have your enthalpy is H2, if it is T2, if it is V2, the volumes, and so on. So if you consider properly, what will be missing, let's say you need to calculate HF. All right, you need to calculate your HF, or is it your HFG, or whatever that you want to calculate. It is the unknown value H that you need to calculate given H1 and H2 for these pressures. From what we can see from this formula, guys, are we seeing that 207 minus 200, this one? It is simply representing the enthalpies that are corresponding to those pressures. Like, let's say this is 1 and this is 2. So it is simply H2 minus H1 if they are now enthalpies on this side. So it will be H2 minus H1. So it is going to be equal to H2 minus H1 over what? The 12 minus 11 that we are seeing here, because it is the same thing that we are also having here, 12 minus 11. It is for the pressures 12 minus 11, those pressures P2 minus what? This is P2 minus what? Minus P1, the given pressures. This is what we saw. 12 minus 11. Then it is now multiplied by the bracket. And the bracket that it is multiplied to corresponds when we're subtracting what? 11,33 minus 11. This is the value of B. What is it representing? The pressure given, the given pressure minus what? Minus P1. This is the given pressure minus P1. Then we ended up adding the minus 200, the one that we started, this one that we are adding the 200 is whatever enthalpy that is corresponding at what? At 0.1. So that is what? Plus H1. So what I'm simply trying to say, guys, is that using this formula, it corresponds to say we need to calculate a certain value from a given pressure P. This pressure P corresponds to whatever value here that you are calculating. Take note. The pressure P corresponds to what you're calculating. So if, let's say, we were to calculate the temperature at that pressure, we need to know what is the temperature at that pressure. It was going to be temperature T is equal to, here, these will be temperatures, these ones, H1 and H2 will be represented as temperature. So it will be T2 minus T1. The pressures, they do not change. P2 minus P1 into P minus P1 plus, this will be temperature, this will be T1. So 1 simply is for the what? For the lower value, and 2 is for what? For the upper value. So you can use this to find whatever. If it was a volume, guys, what it simply means, if it was volume, it was going to be, all right, so take note, at this pressure, you are calculating this value of T, the temperature. So if it was volume, the volume, it was going to do the same thing. These will be volumes V2 minus V1 over 1, P2 minus P1 into this P minus P1 plus what? The volume V1. The volume corresponding to P1. At this pressure, we've got V1, we've got this V1. At P2, we have got what? V2. But at this pressure P that we are given here, it corresponds to the volume that we'll be calculating, whatever that you might be asked from any one of these, TS, V, G, H, F, whatever that you're given there. You can simply use the formula straightforward. You can use that formula straightforward. Straightforward if you can memorize this from this method. This is the formula that you have. So like what you saw here, calculating your HFG and your HF. If we were to use this formula, guys, we can calculate any corresponding value. Any corresponding value is each volume that we need. So if it, let's say we wanted volume, all right, let me just add, I do not want to extend much, but for the sake of revision, let us just extend. So let us say if it was volume, let's say wanted to calculate Vg at what? At that pressure of what? 11,33 kilopascal, the one that we do not have in the formula sheet. What we're going to simply need is what? We already have P1 and P2. Those are the boundaries, pressure 11 and what? And 12. So what we need, because we are dealing with the volume, we are supposed to work with what? With the volumes now at those given pressures. So you're going to ask yourself now at V1, that is at what? At 11, the minimum there. So V1 is what? At what? At 11 kilopascal. What is the value of what? Of the volume there? So this is what you're going to do, all right? At 11, the volume, all right, let us consider we are at what? At 11. So this is it. This is our 11 here. So the corresponding value. So for those who want to use formulas, this is the best way for those who want to apply formulas. But if you are someone who can just memorize, there is no need for formula. You can just take it that way. So like I said, there's another way. I'm going to explain another one and so on. So 11, the volume VG, this is the volume VG at 11. It was going to be 13,42. All right, at 11 kilopascal, your VG was gonna be what? Was gonna be 13,42. All right, 13,42. So that's 13,42. All right, 13,42, which is cubic meters per kilogram. You can even just leave it. Then V2, as we're gonna also need that. V2 is the one that is at the maximum pressure at what? At 12. So at 12 kilopascal, what is the value of what? Of VG? That's your V2, all right? At what? At 12, sorry for that. At 12 kilopascal, your VG is what? 12,36. That's our VG. That's 12, what? 12,36. So that will be your V2 corresponding to that. So it's going to be 12,36, all right? Something like that. So using the formula now, the volume that we need, which is our VG, in this case, our VG, the volume, which corresponds to what? To that pressure. You can write it straight. We can just write V from that formula. You know that is going to be what? The difference between the volumes V2, what you're being asked, V on top, V2 minus V1, the difference between the pressures that you're given into P minus P1, all right, plus that V1, which is here from our formula. So it follows that V2, you already have it. This is 12,36 minus V1, 13,42 over what? The pressures P2 minus P1. Remember the pressures that you had, P2 minus P1, the top minus bottom, 12 minus what? 12 minus 11. All right, so this is it. Into what? P minus P1. P is the one that you're given at that pressure. That's our P, the given pressure. So that's 11,33 minus what? Minus P. Remember your P, this is P2 and this is P1. Minus P1, your P1 is what? Is 11. So this is what you're going to have. Then do not forget to add what? Your V1. V1 at P at 11 kilopascal. This was 13,42. So this will give you the volume corresponding to that. So if it was temperature, you do the same thing, guys. If it is whatever that you're given, you can play around. And this is for just a normal steam table. We are not working with a superheated steam. For superheated steam, there is a formula for that. I'm going to explain it in another class. So make sure that you become part of the membership so that you do not miss any of the other classes that I'm going to have explaining this part and also working with question papers for those who do not understand. Let's say you've got a question that you do not understand. You can join membership so that you'll be able to ask those questions separately. All right, so this is what I was going to obtain. And to 3 decimal places, we can just leave it as what? 13.070 like that, which will be cubic meters per kilogram. That is going to be your VG at what? At that pressure. So you can even use it for temperature, the same thing. Temperature, it will be T1 and what? And T2 for the given what? For the given values of what? For the given values that you have maximum and minimum at P1 and what? At P1 and P2. So as long you know values at P1 and P2, those boundaries in terms of what? In terms of the pressure, then you can memorize this formula, just one formula, you make adjustments from that formula. Or you simply take it the way that I did it from the diagram that you're going to have A and B. You simply consider the difference is A over B is equal to C over D. Or you can use what? Or you can work with the formula. So there are 2 ways that I've explained so far, but I'm going to explain another one in another way. Maybe you can understand that one. So it's going to be part of membership. So make sure you become part of membership so that you do not miss any class that we are going to have or that we are going to consider. So if there is any pressure, guys, that is not in the steam table, but for that pressure, you must determine any one of these from your steam table, any one of these. That method can be applied for any one of these, not for superheated steam. Take note, guys, we are not on the superheated steam. The superheated steam has got its own properties. So make sure that you become part of membership so that you do not miss those classes that I'm going to explain further in terms of the interpolation.